Hello everybody, how is it going? And welcome back to my YouTube channel or welcome to my YouTube channel. So in today's video, we are going to discuss ARP poisoning or ARP spoofing. Besides that, we are also going to learn about different things such as address resolution protocol, like what is ARP protocol and how does it work, IP address and MAC address, ARP request and ARP response, what is ARP Cache, demonstration of ARP spoofing or ARP poisoning attack, where I will show you how an attacker can intercept network traffic doing ARP poisoning and can sniff sensitive information like login credentials without any acknowledgement of the victim. Then we will talk about why and how ARP spoofing works. Then how can we detect ARP spoofing or ARP poisoning attack, and then we will discuss some protection and prevention against ARP poisoning. Timestamps of each topic are in the description box below, so feel free to check them out. Also, if you guys are new on this channel, make sure to subscribe it and press the bell icon so you will be notified at earliest when I will upload new videos related to cybersecurity or programming. Now, without wasting any time, let's just get into the video. What is address resolution protocol? ARP, short for Address Resolution Protocol, is one of the most important protocol of the network layer in the OSI model. We will discuss OSI model in the next video, but just for now, let's know this. So the use of ARP protocol is simple to understand. Whenever a device wants to communicate to any other device on a local area network, this is where ARP protocol comes into play. ARP protocol lets devices to communicate to each other by translating MAC address of a device with its IP address and vice versa. I will show you a demonstration of ARP spoofing attack a bit later using Wireshark, where I will intercept the network traffic on my ETH0 network interface. Now, if we talk about how does devices are identified on a network, then we have two addresses. First one is IP address or Internet Protocol address. It is also known as logical address of a device, which is used to identify devices on a wide area network, in simple words, on the internet. So IP addresses are of two types, IPv4 and IPv6. V here stands for version. IPv4 is 32-bit in length and represented as shown here. Now these IP addresses can be different from what you are seeing here, as the values of each X can be anything in between 0 to 255. These are just examples. On the other hand, IPv6 addresses are 128-bit in length and consist of 8 pairs separated by a colon. Each pair is a group of 4 hexadecimal digits and 16-bit in length. Now 8 pairs into 16 makes it to 128-bit in length. The 3 rightmost groups or octets are called global prefix, and the 4th one is subnet, and the leftmost are called interface ID. As we discussed earlier, IPv4 and IPv6 are both used to identify devices on the internet. Since IPv4 is only 32-bit in length, we are running out of IPv4 addresses. That's why we also use IPv6 addresses now. Then we have MAC address. MAC address, also known as physical address of a device, and are used to identify devices on a local area network. As IP address on a local area network can differ every time a device connects to a network, that's why MAC addresses are used to identify devices on a local area network. It is 48-bit in length and pairs of 6 separated by a colon or a hyphen. Each pair consists 2 hexadecimal digits, and the 3 rightmost groups are called OUI or Organizationally Unique Identifier, which identifies the manufacturer of a device, and 3 leftmost are called Network Interface Controller or NIC. MAC address can be spoofed, and due to this reason, it can be used to bypass any filter for any kind of access control based on MAC addresses. Now let's see how an ARP request or ARP reply happens inside a local area network. I have this local area network where I have 3 computers, 1 access point, a router, and a mobile phone. So let's suppose device A with an IP address of this and MAC address this wants to communicate to device D on this network. For that, an ARP request will be made as shown here. Now this message, who has 192.168.0.106, will be broadcasted over a network, and every device will get this message. Now what will happen now if any device on the network has 192.168.0.106, it will reply back saying I have 192.168.0.106 and my MAC address is this. This reply part is called ARP response or reply. So here, after replying with an ARP Response, an entry will be created or updated which is managed by devices on a network. This entry contains IP addresses and associated MAC addresses of devices. For example, IP address and MAC address of device T, so that's how our protocol helps devices to communicate to each other by translating IP address to its MAC address and vice versa. As I mentioned earlier about the entry that is created whenever our protocol maps IP address with MAC address of a device, now the collection of these ARP entries are called ARP Cache. It's basically a table which consists IP address, associated MAC address, and type of ARP entry which can be static or dynamic. You can view ARP Cache by typing a simple command ARP-A as shown in that figure. By doing an ARP spoofing attack, an attacker can forge the MAC addresses which results creating or updating fake ARP entries in this ARP cache, and this is simply called as ARP cache poisoning. Man-in-the-middle attack can also be achieved by poisoning the ARP cache where an attacker spoofs its MAC address with the MAC address of devices and associate their IPs with his or her device. This results putting the attacker in the middle of the communication of the victim's devices. I will show you this whole thing in the demonstration after a few moments. So ARP spoofing is a kind of attack in which an attacker sends fabricate ARP messages in order to link attacker's MAC address with the IP address of a legitimate device of a victim on a local area network as we discussed earlier. Now let's just move to the demonstration part and see how this attack works by doing this attack practically. So I have this Kali Linux machine connected to my local area network. This is the machine I'm going to be using as attacker's machine, which has 192.168.0.111 and this MAC address. Also, I have two devices which I'm going to use as victims. The device 1 is a computer with IP address 192.168.0.105 on which there is an Apache web server running, and second device is a mobile phone which has 192.168.0.113 IP address. Let me just open Wireshark so I can show you how can an attacker sniff the data packets and can extract sensitive information such as login credentials by doing ARP poisoning or ARP spoofing attack. As you can see here, device with 192.168.0.113 broadcasted a message to every device on a network asking who has 192.168.0.1, which is my router. We haven't started any attack yet. I got this ARP request message is because I told you earlier, whenever a device wants to communicate to any other device on a network, a broadcast message is sent to every device on a network. All I did is just intercepted the network traffic on my machine. So this is what an ARP request looks like on a network. Let's move forward to the attacking part. Now, just for a basic idea, this is how two victim devices communicating to each other without ARP spoofing attack. This figure is only showing request from device C and response from device B, but it can also happen vice versa. Now here, this is how we will manage to intercept the communication between two devices. As you can see, all the data is flowing through the attacker's machine. In simple words, attacker machine is in the middle of the communication between device B and device C, and this is the reason an attacker can now intercept, modify, or even stop the data flow of the communication. Now let's just ping two victim devices, just to double check if they are currently up or not. So both of the victim devices are alive on the network. We can start the ARP spoofing attack now. I'm going to use ARP Spoof tool. This tool comes pre-installed in Kali Linux. In case if you don't have it, you can simply install it using apt-get install command. ARP spoofing can also be done using different tools such as Bettercap. I will make another video for that later, so now let's just do this. So the commands are very simple. First we are using ARP spoof, then -i depicts the interface name. For me it is ETH0, but this also works on any type of local area network. Currently I'm on bridged network, but this attack works on NAT or any other type of network as well, as long as the network is a local area network. -T for specifying the target IP, and the last IP is the host IP. Now half work is done. Let's just split this terminal and execute the same command with few changes. In the second command, we specified the target as 192.168.0.113. Now these two commands has put our machine in the middle of the communication between these two victims' devices. As you can see in ARP reply message, attacker's machine MAC address is associated with IP addresses of victim's machine. Based on this, an ARP cache must have been created in the victim's ARP cache, and we have successfully achieved ARP poisoning. Now let's just go to the Wireshark and intercept the packets of the communication. So the reason here why this mobile phone is unable to access web server is because of this Linux security feature. By default, IP forwarding is disabled. All we have to do is just enable it. We can simply echo out one to this file or just edit it using any text editor. So here now the victim1 web server is accessible by the victim2 machine, which is a mobile phone. Let's just enter some credentials. Now let's just find the right request packet and extract the credentials. For that, we can just scroll up or scroll down and try to find the right packet, or we can just simply filter out using Wireshark filter. So this is the get request packets, which is of no use as the method used on the web server is post. Now, as you can see under form data, we managed to intercept the credentials of victim2 on victim1 web server. Now let's just talk about why and how this attack works. So the reason why this works is because our protocol was not designed considering security measure. Now there are two reasons. First is ARP doesn't verify the authenticity of devices that sends the response of an ARP request, and the second one is this protocol lets host device to accept the ARP responses even if they never sent out any ARP request. Now how this works. The first thing is attacker must have access to the network. Second, they determine IP address of at least two victims' devices on a network. Using any ARP spoofing tool, they achieve ARP spoofing by mapping their MAC address with victims' devices' IP addresses. This forged mapping puts the attacker device in the middle of the communication, and once this been achieved, an attacker can do several malicious things. There are different things that can be achieved using ARP poisoning. Let's just discuss them. So after a successful ARP poisoning or ARP spoofing attack, an attacker can intercept the network traffic between two devices or more devices and can steal valuable or sensitive information such as login credentials, session cookies. Attacker can inject malicious file or edit data. Also, distributed denial of service can also be achieved if an attacker can manage to link the MAC address of a server to a large number of IP addresses. The detection of ARP spoofing is kind of simple. By looking at the ARP cache, if two or more IP addresses associated with same MAC address, this simply means there is a ARP spoofing attack taking place. Like shown in the figure where two IP addresses have same MAC addresses, you can view ARP cache by typing ARP-A respective of the operating system. This command is same for Windows or Linux. Now let's discuss some ways to prevent or protect against ARP spoofing attack. Use of VPNs or virtual private networks allow devices to connect to the internet through an encrypted tunnel. As I mentioned earlier, in the ARP cache, there is a column name type of ARP entry. Now, use of static ARP entry is also a good measure. ARP spoofing detection tools is another good measure, as most of these tools not only detect but also protect from the ARP spoofing attack. Packet filtering is another protection against ARP poisoning. That's all for today's video. If you guys have enjoyed it or it has been informative for you, don't forget to like this video or subscribe to this channel if you haven't done it yet. We'll meet you again in another video. Till then, take care and goodbye.